Okay, so going over the activity of metals lab, you um, need to predict your products when you write out your balanced equation. So, what you're given here is the reactants solid magnesium, and then you added to it aqueous cobalt 3 chloride. And then you are going to say what the products are from this reaction if you saw a reaction. And actually, you do see a reaction with this reaction. So, what is happening? Remember, all you have here is three different types of atoms. You have magnesium, you have cobalt, and you have chlorine in multiple quantities. And so they're going to rearrange. This is a single replacement or single displacement reaction. And basically, magnesium is a metal, and the metals are going to switch places. Their metals are going to switch places. So when I rewrite this, I'm going to have cobalt all by itself and magnesium chloride. Now, the formula for magnesium chloride is MgCl2 because magnesium is +2 and chlorine is -1. It was cobalt 3 chloride because this 3 came from the cobalt and chlorine's -1. Now, you'll notice from your observations that there's like this solid green stuff on top of the magnesium metal, and that's what solid cobalt looks like. And it didn't, you still have a liquid solution there, so this salt is in solution, so it is still aqueous. So these are the products of this reaction. These are the products of this reaction. You started with, here I'll show you, that's this guy. You started with a piece of magnesium. You added the pink cobalt 3 chloride to it, and color's not showing up. And now that is covered with some green, and you can even see um, this green stuff flaking off and falling. That's solid cobalt. It's also not as pink as when you started because the cobalt's coming out of solution, and magnesium chloride is clear, so you can even see it diluting there. After you do it that way, you then have to write it in words. So if I'm going to write this in words, you start from the left to the right, and I'm going to say solid for my S. Solid, Mg stands for magnesium. The plus is and. This is cobalt 3 chloride. Roman numeral. That cobalt 3 is not a number 3. I mean, it's a Roman numeral 3. Cobalt 3 chloride. And this you could write as react to form, or you could just go straight up yields solid cobalt and my plus and aqueous magnesium and aqueous magnesium chloride. So let's see. Solid magnesium and cobalt 3 chloride. Oh, aqueous. My bad. Aqueous. Cobalt 3 chloride yields solid cobalt and aqueous magnesium chloride. So that would be for this square here, plus any observations. Now, you're going to do it for every one that there's a reaction for every square that there's a reaction for. For example, I guess I could ruin the fun for you, but this guy doesn't react. If we look, this tray has been sitting for about an hour now, and that's still just the cobalt chloride and a piece of copper. So we have no reaction there, so you would not have to predict the products here. There's no reaction. And ultimately, what you're trying to find out is which metal. We're using 3 metals. We're using magnesium, we're using copper, and we're using zinc. Which one is more reactive? So, which one is it reacting in all 4 of these squares? And then one of them will only be reacting in 3 of the squares, and one of them will only be reacting in 2 of the squares. So you'll be able at the end to say, okay, this is more reactive because it reacted with every solution I put it with, or this one is least reactive because it didn't react for all the solutions. And it asks you to explain your answer by referring to the data. And so that's kind of what I did. Refer to what you actually do, which is what makes you decide whether a metal is going to be more reactive than another. You're literally just comparing, because notice we use the same solution, the same solution, the same solution in all 3 metals to see how it responds. So individually we can look, but then as a big picture we can look. And then support your answer by referring to the periodic table. Now remember, the periodic table, metals on the left of the periodic table, left hand side, metals more reactive. And like group 1 or alkali metals, you don't really find them in nature because they're so reactive. They just have that 1 valence electron that's really easy for them to lose, and then boom, they're a cation. So they don't really stay neutral in the environment because they lose that electron very quickly. And remember, there is from the notes I gave you what's called like an activity series. Sodium is more reactive than magnesium, which is more reactive than aluminum, and then it's zinc, then it's iron, nickel is in here, hydrogen, remember it acts as a cation, so hydrogen is part of that. Then we have copper, silver, and then Au, gold. Gold is not reactive at all. That's why it can stay looking perfectly like gold for hundreds and thousands of years, because it doesn't oxidize, it doesn't tarnish, it doesn't react with other things. So you find it in the ocean, it still looks exactly like gold. Silver, however, will tarnish. But basically, these are more reactive, and this is less reactive. So basically, anything to the left will replace a metal to its right. So sodium would replace magnesium, and magnesium will replace zinc, and zinc would replace iron, and iron would replace nickel, or zinc would replace hydrogen, or magnesium would replace copper. So more reactive here, less reactive here. And when you look on the periodic table, it goes with the periodic table with a few exceptions. Obviously, you have your zinc, iron, and nickel is in line, but silver is lower than zinc and further right, and gold is even lower than silver. So you do have not the perfect, there is a little wobble, on the periodic table, not the perfect predictor, but you can definitely support these three metals by their position on the periodic table, where magnesium, copper, and zinc is. And don't forget, you're going to take a photo of your plate to turn in on Schoology. You want to wait about 15 minutes, make tons of observations. At the 5-minute mark, you'll know if something reacts or not. So you'll be able to put your non-reactions in. But wait till about 15 before you take the photograph, so that way you have a good intensity of colors or anything changing. Now, let me do one more example for you. Let's do the third one here, where you take magnesium solid, and our copper 2 sulfate, CuSO4 aqueous solution. You mix them together in the well plate. They do react. You see color change, you see bubbling, you see evidence of a reaction. So they do react. And that reaction is the magnesium replacing the copper. So it's going to kick copper out. It's going to replace the copper. So you're going to have copper all by itself, solid, and magnesium sulfate, SO4, and that is aqueous. So looking here, we know that this is copper 2 sulfate, because you should have memorized that sulfate is -2. Now, what I'm writing here, you're not going to include in your equation. But remember, sulfate is -2 oxidation state. Magnesium is 0 by itself, but it easily loses the 2 valence electrons, and magnesium is always +2. Here, since you don't see this 2 here, and it's a 1-to-1 relationship between SO4, remember that's a polyatomic ion treated as a group, one of these for every one of these, if this is -2, this must be +2. And then anything by itself, it has no sulfate, is still -2. Now, remember, these charges you don't write, they just help you write the formulas. And then now we need to convert this to words. So let's see, solid magnesium, and this is a transition metal, so I need to use Roman numerals to describe its oxidation state. So copper 2 sulfate, solid magnesium, and copper 2 sulfate aqueous. I did it again. I should have put aqueous in front. Copper 2 sulfate, I'll put it parentheses, yields solid copper and aqueous magnesium sulfate. Now, magnesium is a type 1 metal. It's in group 2, so no Roman numerals are needed. So this is the naming rules coming back at us, because we're going to keep using those the rest of the year. So this is, I guess, kind of like A, and this is B, because you need to write the formula and you need to write it in sentences. And then also you need to balance, but luckily this one is already balanced. So hopefully that helps you. What you're going to do. Now, this needs to be written neatly on the back. If you can't write it neatly, you're more than welcome to type it up to turn it in on Schoology. And I just really hope this helped you guys. And now, oh, oop, 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 oop. Now I gotta stop recording.